All right, so we're talking about scientific notation. And scientific notation is used for very, very large numbers, like the distance between Earth and Jupiter, or very, very tiny numbers, like the width of one strand of hair. So, or if you're measuring a bacteria or cell. All right. So what you have is you can convert from scientific notation into standard. Standard is how the number normally is. So 500, that's standard notation. And scientific notation has a couple of components to it. It will have a number, a decimal point, some other numbers, and then it'll always have times 10 to a power. And that's what you need to be looking at, the power there. If it is a positive exponent, then you have a large number. So that's that Earth to Jupiter number. If you have a negative exponent, that's your tiny number, or a small number. That is measuring a cell or a bacteria or something like that. All right. So what we're going to do is show how to convert from standard to scientific notation. So let's take a look at the number 500. To write that in scientific notation, I know that I need a number, a decimal, some other stuff maybe, and then times 10 always, and then this exponent, which changes depending on your number. So you're going to look at your standard and you're going to cut it right there at that first digit. That will go here. Now in this case, I have just zeros after it. So I don't need that. So it's going to be 5 times 10 to some power. In order to get the power, after I cut that first number off, I've got 1, 2 digits. So that is what's going to be there, 2. Now let's think about that. Did it work? 5 times 10 squared. Well, 10 squared is 100. Is 5 times 100 my original 500? Yep, sure is. So let's look at another one. All right. And I'll put that as a little blank spot. So this time, instead of 5, I'm going to have 6210784. All right. I'm still going to chop it right there. So the 6 will go there. And then I need a decimal. Now, because I have digits that read all the way out, I need to move those off. I need to write all of them. 6210784 times, I'll change the color for you, times 10. That stayed put. Now, how many place values here? 1, 2, 3, 4, 5, 6. 10 to the 6th power. All right. What if I have this one? We'll go ahead and erase all of these. If I have 7302. All right, we're going to cut it off. Put the 7 there. 302 here. Count off, 1, 2, 3. There you go. Now, let's change this up a little bit. Instead of 302, let's say it was 002. Zero, 0, 2. I still need to account for that 2 being there, for that 2 to exist. So I have to, in my decimal part of this, put in the 0, 0, 2. And then I can put my 3 back up there. I have to account for that because I cannot change the value. That 2 needs to be included. Let's look at a negative exponent. So 3, 0, 0, 0, 2, 4. That's a small number. So for this one, I already know I need 10 times 10. It's a tiny number. It's less than 0, or less than 1, excuse me. So I know I need that negative sign there. All right, so we're going to go travel across until we come to the first digit right there. And that is what's going to go in there, the 2.4. Now, I need to know how far back it went. Well, I have to count my place size again. So it traveled 1, 2, 3, 4. So that's to the negative 4. All right. Let's try another one to show you. So .608, I'm going to have times 10 to the negative. Now, on this one, I only needed to move it 1 spot. So it's negative 1, and it's 6.08. Now, this is all well and good, but what if you were going from standard? Well, we did standard to scientific notation. What if you start out with scientific notation? Let's look at that. 4.0027 times 10 to the negative 4. All right. Well, my 4.0027, because it's a negative exponent right here, I know I'm going to have a decimal. So my way of building it is I'm going to go ahead and jump up here. So 4, and then I'm going to write all of this. 0027. Okay, now I need to get negative 4. So my places have to go that way. So it was starting right here. I need 1, 2, 3, 4. My decimal is going to be here. My new one. So 1, 2, 3 leading zeros. So truthfully, when you look at these small ones, this number here, that 4 here, has to occupy that spot. And then there's zeros in front of it. And then all the rest of it follows behind it. Let's look at another one. If I have 1.49 times 10 to the negative 7. Okay, well, let's take a look at that guy. We're going to have 149. This 1 has to be in the 7th spot. So I'm going to have 6 zeros in front of it. 1, 2, 3, 4, 5, 6. Bam. All right. Now we didn't look at a large one, so let's do that as well. If I have 6.1 times 10 to the 4th, I know I'm going to need 6. And this point and this 4, I'm going to need 1, 2, 3, 4. So the 1 was here, and then my zeros drop in. All right. One more of these, and we have 2.91 times 10 to the 5th, large number, positive exponent, 291. I need 5 place values after that 2, after that decimal, so 1, 2, 3, 4, 5. There you go.